Next we see the topic of effect of intensity of incident radiation on the photoelectric current. Before that, we see about experimental arrangement for the photoelectric effect. So in this experiment, it consists of quartz bulb. They have in the quartz window, S is a source, and this quartz consists of two metallic plates C and A, that means anode and cathode. It is a evacuated glass tube. It is a evacuated glass tube, and the plate A is connected to the potential divider through the microammeter. Okay, and the plate C is connected to the center part of the potential divider PQ, and this potential divider is connected to the battery through the key, and across it we are connecting the voltmeter. Okay, and when we pass the electromagnetic radiation through this window, it is incident on the photosensitive material of the plate C. It emits an electron. All the emitter electrons are collected by the plate A. That means it reaches the plate A. So it produces a current. Such a flowing of electrons from the plate A, C to A to generate the current. Such a current is photoelectric current. Due to the flowing of current, microammeter show the deflection and voltmeter show the positive side deflection. Here the voltmeter is designed, the pointer is marked at the center is 0. Pointer marked at the center of the voltmeter is 0. This side positive, this side negative. Okay. When there is no light is passing on the plate C, does not emit the photoelectrons, and microammeter show the 0. Okay. At the same time, when we pass the same radiation to the plate A, does not emit the electrons. At the same time also, the microammeter show the 0. Okay. When the light is allowed to fall on the plate C, it liberates the electrons. All the emitted electrons are collected by the plate A, and it generate the photoelectric currents. This was measured by the microammeter. Okay. So from this experiment, here we are going to study about the variation of photo current with respect to the intensity of the incident radiation, and the potential difference between these two plates, and the nature of the material, and the frequency of the incident radiation. Okay, that means here we are going to discuss about the photoelectric current with respect to intensity of the radiation, and the potential difference between these two plates, and the frequency of the radiation. First we see about effect of intensity of incident radiation. When we expose the light to the plate C, electrons are emitted. Such emitted electrons are reaches the plate A. Here plate A is positive with respect to the negative. All the emitted electrons from the plate C, it was attracted by the plate A. A. Now it produces a photo current. When we increase that means when we vary the intensity of incident radiation, the flowing of photocurrent is also varied. If we increase the intensity of radiation, increase the photocurrents. Increase the photocurrent. The increasing photocurrent was measured by the microammeter. Okay. When we draw the graph between the intensity of incident radiation and our photocurrents, it will be linearly increased. It will be linearly increased. As the intensity of light is taken as x-axis, photocurrent is taken as the y-axis. As the intensity of light is increases, emission of current electrons also increases. That means electric current also will be increases. While we study about the effect of intensity of photoelectric current, frequency and our potential between the two plates is kept as the constant. Frequency of the radiation and the potential between these two plates is kept as the constant. Here we are going to vary only the intensity of the radiation. Going to vary only the intensity of the radiation. As the intensity of the incident radiation is varied, photocurrent also varied. Both are increasing linearly. Okay. So this photocurrent is increases as the intensity of light is increases. So number of electrons emitted per second is directly proportional to the intensity of the incident radiation. Both are directly proportional. Okay. So from this we know that from the graph we know that intensity of incident radiation is directly proportional to the number of electrons emitted per second. This is the effect of intensity of the incident radiation.